Okay, let's look at the question together. The time in number of days until maturity of a certain variety of hard pepper is normally distributed with mean mu and standard deviation equal to sigma. Both mu and sigma, they are unknown to us. The variety is advertised as taking 70 days to mature. I wish to test the hypothesis H naught mu equal to 70 against HA mu greater than 70. So I select a simple random sample of 4 plants of this variety and measure the mean until maturity. The 4 times in day are 76, 73, 69 days, 70 days. Based on the data, what can we say? We want to do statistical inferences. Use what? Use hypothesis testing, okay? You want to copy, go ahead and think about it, okay? I'll give you 2 minutes. Okay, let's look at here. For this question, the variable of interest is X. Let X be the number of days for the hard paper to mature, okay? And from the given information, we know X follow normal distribution with mu and sigma. Mu is population mean, sigma is population standard deviation. And in this case, both mean and population standard deviation are known to us, okay? Are known to us. And what we want to do, we want to estimate mu. We want to estimate, make a statistic inference on mu, okay? Now, we're gonna use hypothesis testing p-value approach. Step 1, H naught mu equal to 70 days against HA mu greater than 70 days. Step 2, as usual, we choose alpha equal to 5%, okay? Now, in the final exam, if I don't give you the level of significance, you try to choose what? Alpha equal to 5%, okay? This is the rule of thumb. Most statisticians like to choose alpha equal to 5%. Step 3, test statistic used. We use sample average X bar to estimate population average, okay? And our decision is we're going to reject H naught if p-value less than alpha. These are all standard procedures, okay? Okay, let's move on to step 4, okay? Step 4. Step 4 deals with calculations. X bar, the sample mean. It is 76 plus 73 plus 69 plus 70 divided by 4. And this gives 72. And then sample standard deviation. 76 minus 70 squared plus 73 minus 70, let's see. This is 72, sorry, okay? Average is 72, right? So this is 72 squared plus 69 minus 72 squared plus 70 minus 72 squared divided by 4. Since this is what? Sample standard deviation divided by 4 minus 1 by 3, okay? Sample divided by what? Sample size minus 1. Okay, sample standard deviation, sample size minus 1. And this number is roughly equal to 3.162. Okay, roughly equal. Now, next one, we want to compute p-value. And what's p-value? By the definition, okay? By the definition. P-value is under the assumption that H naught is true. How likely test statistic behave at least as extreme as the observed value. Okay, that is a definition of p-value. Okay, so let's take a look. X bar. Okay, since X bar is our test statistic, in order to make statistic inferences, we need to know its distribution. Okay, let's see. X bar is x1 plus x2 plus x3 plus x4 divided by 4. And we know normality is closed under linear combination. We assume x1 follow normal, x2 follow normal, x3 follow normal, x4 follow normal. Normal random variable add up with normal random variable. Still what? Still normal random variable. A normal random variable times a constant. Here we times 1/4. Still what? Normal. This is called normality. It's closed under linear combination. Okay? So this is follow normal. With the center, Ex bar is equal to mu. Okay, Ex bar is equal to mu. But what do we know about mu? Under H naught is true. Okay, under H naught is true. Under the assumption that H naught is true. 70 days to mature. Okay, 70 days. So under H naught is true. Under the assumption that H naught is true. Okay, under the assumption that H naught is true. The day to mature is 70 days. Okay? And this is what we expect to see under H naught is true. But what we actually observe is not 70 days, it's 72 days. This is what we actually what? Observed. Okay? Under H naught is true, we expect to see 70 days, but what we actually observe is not 70 days, it's 72 days. Okay? So recall, okay? Under H naught is true, we expect to see 70 days. Now we see 72 days, okay? Under H naught is true, what we observe should close to what we expect. If this doesn't close to what we expect, further deviates from the expectation, that's called extreme, okay? So this area, okay? Why this is extreme? Because this kind of data support HA is true, okay? Don't support H naught is true. So this is called extreme, okay? So the size of the tail area is our p-value. And our next job is to find the size of the shady area, okay? So before we do that, let's concrete what? Concrete this description here, okay? Under the assumption that H naught is true, okay? Mu is equal to 70. The test statistic, we use X bar the sample average to estimate mu. So this is our test statistic. And what is the observed value of this test statistic? We observe 72 days. Under H92, okay? If we expect to see what? The observed value should close to what we expect, which is 70. If this doesn't close what we expect, further deviate from the expectation. That's called extreme. So this is greater or equal to, okay? We want to find what? We want to find this probability. This probability is p-value, okay? Okay, our next job is find the size of the area, shady area, and that shady area is p-value. Okay. In order to find the size of the shady area, we need to standardize X bar, okay? Standardization is always go this way. A variable, subtract by what? By its mean, divided by standard deviation. Okay? It's X bar, EX bar is mean. And variance X bar is sigma squared over n. Okay? Now, we can further simplify. As X bar minus mu, this is sigma over square root n. However, we don't know sigma, it's unknown. If we know, this will be z, okay? It's called one sample z. But in this case, we don't know sigma. We have to estimate by sample standard deviation. By this replacement, the resulting variable is no longer follow z. It's actually a t, okay? T with how many degree of freedom? N minus 1 degree of freedom. In our case, n is 4. 4 minus 1 is 3. So the distribution we're going to talk about now is T with 3 degree of freedom, okay? And let's substitute the number, okay? X bar minus mu under H92, mu is 70. And we calculate S, that's what? 3.162 divided by square root of 4, and that's 2, okay? So this number is X bar minus 70. This is 1.5A1, okay? 1.5A1. So this is a way how we standardize 72. 72 minus 70 divided by what? 1.5A1, okay? This is a p-value. So the p-value, okay? We will find this one shortly. So p-value is actually equal to T with 3 degree of freedom greater or equal to what? 1.265, okay? And our next job is find the size of what? This tail area, okay? 1.265. Now let's look in here. P distribution, just like a normal distribution, is bell-shaped, center is 0. But P distribution have what? Fatter tails. Look at the upper tail. Huh? Probably T3 greater or equal to 1.265. This is a p-value. So the size of this upper tail is what? The p-value. How can we find the area? Okay, let's go for your textbook. Okay, the construction of your textbook is like this. First, you look at what? Degree of freedom. right? 3 degrees of freedom. Now, depends on you want to do interval estimation. You need to tell me what's the confidence level. Usually 95%. If this is inference, use what? Confidence what? Intervals. Then the critical t-value is 3.182. But this question, we are not building confidence interval. We want to do what? Hypothesis testing. Do hypothesis testing, we look at the what? We look at the bottom of the table. Depends on is one-sided alternative or two-sided alternative. In our case, HA is one-sided. Mu greater than 70 is one-sided. So we look what? Look at one-sided P. Okay? Now, look at here. Our calculated what? Our calculated t-value, 1.265. Okay? Look at here. 3 degrees of freedom. You move a finger along. 1.265 is bigger than this one, but smaller than this one. Bigger than this one, let's look at here. 1.25, you move the finger down, you find one-sided P is what? 15%. Okay? For the other number is what? 10%. And what does that mean? Okay, let me show you. As we just show you, this number is 1.25. Another number is what? 1.638. Okay? We also check the corresponding upper tail is 10%. And this one and onward is what? Is 15%. Okay? So what can you say about p-value? P-value is bounded by what? By these two. Okay? Bounded by these two. So that means probability that T3 greater or equal to 1.265 is smaller than T3 greater or equal to what? 1.25. Okay? This one from the table is 15%. And the other side, T3 greater or equal to this number, 1.638. From the table, you find this is what? This is 10%. So we know p-value. This is p-value. We know p-value is between 15% and 10%. Okay? P-value is between 15% and 10%. Okay? So since p-value greater than alpha equal to 5%, okay? We fail to reject H naught. Okay? But for the test question, we leave alpha open. Okay? So let's see. Look at here. Huh? Which answer is it? We would reject at what? 10%, but alpha not 5% level. B, I will reject H naught at 5% level, but not 1% level. C, I will reject at H naught at what? 1% level. Look at this question here. Okay? This is smaller than 15%, but what? Bigger than 10%. So the answer is I would reject H naught at level of what? 15%. Because this probability is smaller than 15%. Okay? So I will reject at level 15%, but not at level of what? 10%. So the answer should be what? Choose D. Okay? Choose D. None of the above, okay? None of the above. Now, p-value less than 15%, so you reject at 15%, but you don't reject what? 10%, because p-value is bigger than 10%, okay? This is the answer.